I've decided I think I'm going to have to treat you guys like I do my algebra classes and call on random people.
Oh.
Yeah. Okay. Well, then we're going to get a little more interaction.
I have one written down, but now that I'm thinking about it, I don't know if it's right.
Okay. Well, let's hear it.
It's 2 times 5 to the n minus 1.
So it should start a sub n equals. That's like our y equals,
Oh.
right? To make a formula. And you said 2 times 5 raised to the n minus 1.
Yeah, but I can't remember if I did that.
That is it.
Oh, good.
How do you know when to use like the 3 formulas that were on the notes?
You could use. I would use either the first or the last one. The first one, it says a sub n equals, this is the first term in the sequence. So whenever you know the first term in the sequence, you could use this one. If you don't know the first term, then that's when I would use the last one, because a sub k is just any term that you know in the sequence. Because if you think about, on that last formula, if you plugged in the first term, then what's your k? 1. So then the exponent becomes n minus 1. It's the same as the first formula. The first and the last are really the same thing. The first one's just a simplified version because you know it's the first term. Any questions about how to find, like, a sub k is the first term, or a sub 1 is the first term? Everybody's good with why that's 2? Is everyone good with finding the r is 5? Just how much am I multiplying by each time? If you're not sure, you could divide. Just pick one and divide it by the one right in front of it. Right, to find r. Okay, good talk. Number 2.
We did number 2.
We did number 2 together?
Yes, because I had it backwards and it was negative exponent.
Is everybody good with that? Did everybody see 2 on the board? I think I did 2 in my other class too. What about 3?
I did 3A.
3a, pretend like the sequence is arithmetic. Then the next term in the sequence is 44. Because what is my common difference? Right, we're adding 11 each time, if it was an arithmetic sequence. Any questions on 3a? 3b, what if it was geometric?
I got 49.5.
That is correct.
How did you do that?
Okay, going back to, what was the answer for that?
On 2? The common ratio is 2. So r is equal to 2. And then the a sub 1 is 6. How'd you get 49.5 on this one?
I wrote down 22 times 1.5 over 2 minus
33 divided by 22.
Over, what did you say, 2 minus 1?
1. Yes.
Yeah, 22 divided by 11, or 33 divided by 22. What did you get if you did that? 33 divided by 22.
1.5.
Yeah. So the common ratio here is 1.5. So remember I told you if you're not sure, like it's easy on 1 to see what the common ratio is. But on B, that's a little trickier. Just divide. Pick your bigger one, divide it by the one right before it. 33 divided by 22 will give you that R. These lessons aren't supposed to be hard. Sorry, something's in my throat. What's our confusion?
I just didn't know how to do the combination part because it wasn't going to be a whole number.
Okay. Did that answer that question? Divide?
Yeah.
bigger one divided by the one right before it. Anything else? Okay, sure. 4. I love my job. The first week of July was the opening week of the Deluxe Hotel. It had 200 guests that week. In the weeks immediately following this, the bookings decreased by 5% each week. How many guests did the hotel have in the third week? It is 181. What was our formula? A sub n equals A sub 1, which is 200 times 0.95 to the n minus 1. Did we talk about this one in here too?
We talked about the common ratio part.
So everybody's good with where 95% comes from? To me, that's the trickiest one on here.
Where does it come from?
We're decreasing by 5%, which means we're keeping 95% of our customer each week, customer base. So just 100 minus 5% gives me the 95%, 0.95. Again, it makes sense because my common ratio is less than 1. So what happens when this number is less than 1? It's going to be a decrease. It's going to be a exponential decay problem. Okay, so if you plugged in for 3, you would have gotten, it looks like 180 and a half. We can't have half a guest, so we're going to say there's 181 guests. What about on the 11th week? It's around 120. And then B says write the rule, so right here's B, right? The greeting card, you're fixing to. The greeting card selections at stores are regularly updated and new displays are set up each season. Each style of card comes in a multi-pack with the corresponding... Man, I've heard that word said like 3 ways. Yeah, envelopes. That's what I say. Envelopes. Or envelopes. Or I've heard people say envelop. I'm just telling you. These packages must be opened and then placed in the correct slot. Jerry's job is to stock greeting cards at a variety store. Jerry has already stocked 3 packages by the time her shift officially starts. She needs to get paid more. Additional information about the number of packages she has stocked at various times in her shift is given in the table. A, what do you notice about the information in the table?
Doesn't it increase by 35?
Okay, so it looks like the Y's are going up 35. Does that hold again here? Is that one up 35? It is. And then up 35. What are the X values doing? Increasing by halves. And a half. So, huh? Yeah, no kidding. So, what do we notice? So let's be very thorough here. The number of packages stocked each hour. That doesn't sound like me, but that's what they wrote. The number of packages stocked is going up. So I would just say the number of packages goes up by 35 every half hour. Here's theirs. The number of packages stocked is going up by 35 packages during every half-hour interval. So again, that sounds a little bit more proper and well-spoken, and they haven't lived on Sand Mountain their whole life.
Maybe she gets paid for the number of packages she stocks.
Maybe. It doesn't say, does it?
I hope that's the case.
B, at what rate is Jerry stocking the packages? We just... 35 every half hour. That's right. There's nothing wrong with that. That's not the answer they gave. I guess they wanted to make it a unit rate. You guys remember unit rates? That's 7th grade. Unit rate needs a denominator of 1. So if I wanted a 1, yeah. If it's 35 packages every half hour, 70 packages per hour. Is everybody good with that? I mean, it doesn't explicitly tell us that, so I don't feel bad about not knowing that answer. Okay, that's very close. That's an expression.
Oh, well, P of X equals.
Yeah, there we go. P of X equals, that's how picky they'll be on the test, I'm just telling you. Equals 70x plus 3. Because this is a constant rate of change that has a common difference, what do we think in our heads? We should be thinking it's a linear relationship. It's a line. Y equals mx plus b. B is the y-intercept. That's what she started at. She started with 3 packages started. 3 packages stocked when x was 0. And then we're increasing by 70 every time x goes up 1. Nice. 3, if Jerry has to stock 150 packages of cards, how long will it take her? Yeah, you're going to need that. How would we figure it out? It's what? 147. Yeah, okay. So, yes, that's true. We're plugging in 150 for y, right? 150 for p of x. So we could say 150 equals 70x plus 3, and then we're solving for x. So subtract by 3, which is 147 equals 70x. And then here's what you guys were saying. Take 147, divide it by 70. So x equals 2.1 hours. What is that in our time? What's 0.1 hour? It's not 10 minutes. 6 minutes. You know how you can find that? Multiply what by 0.1? Yep. Take your 0.1 at the end, multiply it by 60. Because think about it, if it was half, if it was 0.5, you multiply it by 60 to get to 30. Like we know half hour is 30, but think about the math behind that. Okay. Anyways, it didn't matter in this one, but just in case, it asks you hours and minutes. Yep. Because if you think about it, 6 minutes, there's 10 6-minute intervals. So that means she did 7 packages 10 times in an hour, which is it's fun. 4, the greeting card industry is on the decline. Oh, everybody's doing e-cards. In 2020, Americans purchased approximately 6.5 billion greeting cards each year. Between 18 and 2023, this number has continued to decrease at approximately 2.8% per year. That's probably because you can transfer COVID on it. Anyways, according to this estimate, how many greeting cards were purchased in 2021? So when I think about this, anybody? I don't want to tell you what.
The same as the check your progress to like the last page.
It's very similar.
Yeah, and so you do 6.5 billion times 97.2.
I like it.
Point 97.
So we're going to take the number that we're at and we're going to multiply it by what? 0.972. Because if we're decreasing by 2.8%, that means we are selling 97.2%, which is 0.972. So I could multiply this way. And what do we get? You can just put in your calculator 6.5 times that number and then just say that billion. You don't have to type in 6,500,000,000 if you don't.
6.318 billion.
That's it. Here's a different way that they did it. So I want to show you, like, if you don't think about it the way I think about it, they actually did it differently here. They took what they sold last year and they're going to subtract. They found what is 2.8% of 6.5. To me, I think that's an extra step. This is the same thing. These are the exact same number. It's the exact same logic. Both work every time.
If it was saying like 2022, would you have to do n minus, raise the percent to n minus 1?
You could just raise the 0.28 to the.
I got
Second. What is the ratio of greeting card purchases from 2021 compared to 2020? No. They're talking us through. Okay. So, what were the purchases in 2021? 6.318 in 2021 compared to 2020, which is 6.5. So what is 6.318 divided by 6.5? They're just showing you the step that I've already kind of talked you through how to get that. We're following just another way to find that 97%. Cool. Okay. Six, complete the table. Can you complete the table? Do you need my help to complete the table? Nah, you don't need my help. We've already found this number. That's not what it says.
Oh, never mind.
I like that call. That's not what it says, though, is it?
No.
It says from 2018 to 2023, it's been declining. I just don't know how to interact with you guys. I just don't. There we go. That's what I needed. Yeah. Yeah. You see how they like talk to each other? Yeah. So I can't decide if, like, one, you're so confident in the math that you're not going to ask each other questions. I know that's not the answer. I'm just throwing that out there because you've talked to me about it. Or two, are you too scared to ask someone? Are you too scared to be wrong? Or are you... Anyways, I don't know. Or are you just shy? Okay, good. Talk. 2022. What did we get on 2022?
6.141.
It is?
Oh, that's correct.
Is everybody good with that? What about in 2023?
5.970.
Mine says 969, but they could be wrong.
Oh, I rounded.
Okay,
Yeah.
can we do this? Cause I don't have a clue what I'm doing.
Uh-huh. So we're growing by 0.972 each time. So we should multiply 6.5 by 0.972. And then take this number and multiply it by 0.972. And then take this number and multiply it by 0.972.
Okay, so where does the n minus one thing come in?
For the formula. We don't have a formula yet. We could make this into a formula if we wanted to. So if we wanted to, we'd have to use that last formula. And it would be, I'm sure that they're going to ask me that in just a second, right here. So let's just go ahead and do 8. It would be g of x equals, what's my, a sub 1 I don't really know, but I know a sub k. A sub k is 6.5 times the ratio was 0.972 raised to the n. In this case, n is x minus, and then what was 2018? Or sorry, the one I gave here was 2020, which was 2 years after 2018. So I would subtract by 2. Because we're starting at 2018 here. The n minus 1 is only when we know the first term in the sequence. And here we don't really know the first term yet. Is
So
it?
it's n minus k.
Yes. And here it's just because of the way that it's worded. It says the number of greeting cards purchased X years after 2018. So because I'm at 2020, that's 2 years after 2018. That's where I get the 2 from, because that's the year I knew. If I knew 2019, it would have been a 1. If I knew 2022, it would be a 3. Maybe. There's also another formula that will work if we can fill out the rest of this table. So what was above 6.5?
6.687.
Yep. And how did you get that number?
I divided.
Yep.
0.972.
Yep. Divide by 0.972. And then do that again to find 2018, and you should get,
0.880.
yeah, is everybody good with that? So another way we could write this formula here, because now then we know what it was in 2018. It is 6.88 times 0.972 raised to the x. I can show you some ways you could manipulate this exponent, but I don't think I want to do that right now. If you know about your exponent rules, you could see maybe how you could go from this answer to this answer. Maybe not, that's fine. Okay, just don't worry about it. 7, I told you that's not the important part right now. Is the number of greeting cards purchased annually decreasing by the same amount each year? No. What's happening?
Decreasing by a constant percentage.
It is decreasing by a constant percentage, And so because of that, what's happening to the decrease each year? So like, look from 2018 to 2019, how much did I go down? I went down by nearly 0.2. Right, it's like 0.193. What about from 2019 to 2020? Going down by 0.187. You following what I'm doing here? What about from 2020 to 2021? We're going down by 0.182. And so what's happening to the decrease? So it is decreasing, but this decrease is getting smaller. Right, from almost 0.2 to now we're down to 0.16. That's what growing by a percentage does, because there's less to start with. So if I lose that percentage the next year, I'm not losing the same number. I'm actually decreasing my loss, even though it's still decreasing by the same percentage. To follow, like on a per unit. Okay, anyways. No, I'll just shut up. The year-to-year decrease is getting smaller. So g of x doesn't have an exponent. P of x doesn't have an exponent. Yeah. So because it's linear, what kind of sequence would that have been? Arithmetic sequence. Arithmetic sequence look linear. What about g of x? It was.
Geometric.
It's geometric. Those are some similarities. Or sorry, they're both sequences, I guess, is a similarity. Difference, though, they were different kinds of sequences. P of x was always increasing. What about g of x? It's always decreasing. So those are differences. How are they the same? They are both sequences. They really don't have a good way of saying they're the same either. They say, well, I'm going to show you what they say, and I'm going to see if you can simplify it. Here's what they said. They both follow a predictable pattern from one output to the next. Yeah, I read that as their functions. A function means every input has exactly one output. We can predict the next one because we knew that's just a fancy way to say their functions. Function P has a common difference, and the function G has a common ratio. G has a constant percentage decrease, where P had a constant amount increase. Both were either only increasing or only decreasing. P of x is an arithmetic sequence, where g of x is a geometric sequence. Here's another similarity. They both had an initial value. Right? They both started somewhere. It's not much.